Now let us talk about sequences and series. When numbers are presented one after the other in an orderly manner, we then refer to the set of numbers as sequence. For instance, this three set of numbers, it has a rule. Let's look at the first set. You add 4 to any of the term to get the next term. So 1 plus 4 will give us 5. Then 5 plus 4 will give us 9. 9 plus 4 will give us 13, and so on. Then for the second set of numbers, the rule is you multiply any of the term. For this first term, multiply by 3. You multiply it by 3, you get the next term, which is 6. 6 times 3 will give us 18. 18 times 3 will give us 54, and so on. Then for the third set of numbers, let us look at it closely. 1925, it has to do with square. Okay, the square of consecutive odd numbers. That is the rule to this one, the square of the consecutive odd numbers. After 1 is an odd number. The next odd number, which is a square, is 9, and the next square number, which is an odd number, the next square, which is an odd number, is 25. The next one after 25 is 49, and so forth. So now let us go over to the next video, where we shall be talking about arithmetic progression and geometric progressions. Now let us talk about arithmetic progressions. The sequence of this set of numbers has a first term, which is 9, and a common difference of 3. You can see between 9 and 12 is 3, between 12 and 15 is 3. A sequence in which the terms either increases or decrease in equal steps is called arithmetic progression, usually for short AP. The following sequence represent a general arithmetic progression, that is, the first term, then the next number is the first term plus the common difference, then the first term again plus 2 times the common difference, then a plus 3 times the common difference, and so on. Now let us talk about nth term of an AP. Conventionally, we denote the nth term of a sequence by UN or TN, and that of the first term is A, okay, while that of the common difference is D. So let us represent let n represent the nth term, okay. So now first term is A. The second term is A plus D, while the third term is A plus 2D. The fourth term is A plus 3D. Then for the nth term, it is A plus bracket n minus 1 bracket D. Okay, so in the next common videos we shall see the application of this theory that we have just discussed. Now let us solve this example of arithmetic progression. Find the ninth term of the arithmetic progression of this set of numbers. The first term, which is A, of this set of number is 18. Okay, while the common difference, if we look at it closely, it decreases from 18 to 12, then from 12 to 6, then 6 to 0, 0 to minus 6, and so on. It shows that the common difference D is equal to a negative value of 6. Okay, and remember the general formula for nth term, which is un equals A plus bracket n minus 1 bracket D. And this time around we are to find the ninth term. Okay, so we already know the term, so u9 equals the first term, which is 18. Okay, then the ninth term, the n is the ninth term, 9 minus 1, the common difference is minus 6. So now we simplify further. So 18 plus 9 minus 1 is 8. 8 times minus 6 will give us minus 48. Okay, so 18 minus 48 will give us minus 30 as the ninth term of this set of numbers. Now let us solve another example. If the 11th term of an AP is 42 and its first term is 2, find the common difference. Also, we're still going to use the nth term formula, A plus n minus 1, then D. The Tn is the 11th term, which is given in the question as 42, and the first term is 2. The n, 11 minus 1, that is 10. Then the common difference is what we are looking for. Okay, so now 42 equals 2, then plus 10 times D, we have 10D. So now we still try to find D, so we subtract 2 from both sides of the equation. At the same time we write the left hand side on the right hand side and the right hand side on the left hand side. Okay, so now we have 40. So we go ahead to divide both sides of the equation by 10. Okay, 10 cancel 10 out, 0 cancel 0. So now we have D equals 4. So the common difference is 4. Another question. The 11th term of an AP is 25 and its first term is minus 3. Find the common difference. Still, we use the n-term formula, which is equal to a plus n minus 1 bracket d. The nth term is given, the 11th term is given as 25. Okay, then the first term is also given as minus 3. Then the nth term, which is 11 minus 1, that's 10 times d, we have 10d. Okay, so now we go ahead to add 3 to both sides of the equation. At the same time, we write d on the left hand side. Okay, so we have 25 then plus 3. By the time we add plus 3 here, this one will be gone. Okay, so now we have 25 plus 3, which will give us 28. So we go ahead to divide both sides of the equation by 10 in order to find d. So 10 cancels 10 on the left hand side. Then we have, let's still leave the answer in fraction. Okay, so we divide, 2 goes in here, that's 14. Then 2 in 10, that's 5. 5 in 14, we have 2 whole number 4 over 5. So the common difference is 2 whole number 4 over 5.